So what is probably confusing is that we have so many options, especially for the double angle formula for cosine. To me, this is the complicated side for all kinds of reasons. It's algebraically a lot of things going on. Anything involves the double angle formulas. So what if we just express the right-hand side in terms of just alpha, not 2 alpha? We might just have tangent alpha pretty easily. So the right-hand side is, now sine of 2 alpha is 2 times sine alpha times cosine alpha. And tangent alpha is clearly sine over cosine. So this should remain in the denominator, but this should go. And how can we cancel out from a fraction? We have to divide upstairs and downstairs by the same thing. That means that somehow this should be a product. And if you think about the cosine, the double angle formula for cosine has 3 forms. We should be able to factor one after we substitute it into here. So that's cosine squared alpha minus sine squared alpha, or 2 cosine squared alpha minus 1, or 1 minus 2 sine squared alpha. And so this needs to go. So in order to cancel out, it should appear in the numerator. And if we subtract this, we cancel out the 1. So we have better chances for factoring. So let's try 1 minus, in the parentheses, 1 minus 2 sine squared alpha. And then we have 1 minus 1 plus 2 sine squared alpha, which I'm going to rewrite as sine alpha, because these two cancel. And so what we have is tangent alpha. Okay, so let me show you why this is an important formula. The double angle formulas are recipes how to go from single alpha to double. To get to sine of 2 alpha, just take 2 times sine alpha times cosine alpha. And so on. Now this one is kind of operating the other way around. It says tangent alpha, you can get it from these double angle formulas. So I'm going to show you something that's very, very typical to calculus. And that is sort of reparametrizing the problem. Alpha and 2 alpha, we can think of it in 2 different ways. From this writing, it looks like what we're stating is that this guy is twice that. But we can rephrase the same connection to say that alpha is half of the other one. So here is how it goes. Let 2 alpha be beta. And then divide both sides by 2. Alpha equals beta over 2. And if you rewrite these two guys, 2 alpha is now beta, and alpha is now beta over 2. It's the same connection, but now the emphasis on sort of this is half of that. And so let's see what happens if we rewrite this identity using this parametrization. So tangent of alpha is beta over 2 equals to 1 minus cosine 2 alpha. 2 alpha is beta. And so what we get is what we call the half angle formula for tangent, right? In terms of beta, you need both sine and cosine beta, but this is how you concoct tangent of half of the angle. And as it turns out, there is something almost magical about tangent of beta over 2. There's going to be a lot of trigonometric substitutions in calculus that for somehow tangent of theta over 2 is going to be the magic cure. Somehow it solves a lot of problems. You're going to see that in calculus too. But basically, the half angle formula is not that far from the double angle formulas. It's just we're looking at the same connection from a different perspective. This is actually what we're going to call that. This is the half angle formula for tangent. Thank you for watching.